Hey guys, so today we're going to be talking about the heat equation, which is Q equals mc delta T. And so this has many different values within it. Q, which represents heat, m mass, C, which is the heat capacity, and delta T, which is the temperature change. And using this equation, you can solve for each of these one components, just making sure that your units are lined up, of course. So let's jump right into it. So Q, which is heat, and Q is in joules, and depending on what you're looking for, you may have to switch this conversion to kilojoules or from kilojoules to joules. That just depends. So it can be represented in joules or kilojoules. M, which is mass, and mass is represented in units of grams, so the weight, and that will be given in the equation typically. C, which is the heat capacity, and the heat capacity is represented in terms joules over grams times degrees Celsius. And more times than not, the heat capacity you will be using will be the heat capacity of water, which is 4.184 joules per grams times degrees Celsius. And finally, delta T, and delta T is the change in temperature. So change temp, and so, of course, when you're looking for the change of something, you will subtract the initial from the final. So it would be T final minus T initial. And that will give you your delta T. So with this equation, of course, it solves for heat. And moving back to heat real quick. So if Q is negative up top, looking at heat, a negative Q equals exothermic because heat is being released, and a positive Q is endothermic because heat is being absorbed. So this equation can be used to solve any of these one components given that the units are matched up and lined up. And with that being said, let's jump right in it. Okay, so the problem. Calculate the specific heat capacity of titanium if a 43.56 gram sample absorbs 0.476 kilojoules as its temperature changes from 20.13 degrees Celsius to 41.06 degrees Celsius. Okay, so the first step to any problem is to write out the equation that will be used. So the equation we're going to be using for this is Q equals mc delta T. Okay, and really quickly, let's just remind ourselves about what each value represents. So Q represents heat in kilojoules. And a negative Q means this is an exothermic, and a positive Q means it is endothermic. So exothermic, heat being released, and endothermic, heat being absorbed. Okay, so now M is mass in grams. Okay, C is heat capacity, and this is represented in joules per grams times degrees Celsius. Okay. And then delta T is the change in temp. And this is in degrees Celsius as well, because right here, heat capacity. So this is represented in degrees Celsius. You do not need to change to Kelvin. So with that being said, let's jump into the problem and start assigning values to letters. So the first value given is 43.56 grams, which will be used as our mass. So we have M equals 43.56 grams. Okay. C, heat capacity. There looks like there is no heat capacity in this, so we'll put a question mark. 0.476 kilojoules. Q, 0.476 kilojoules as stated in the equation above. That is our heat, and because it is a positive value, it is heat being absorbed. And now delta T, we have our two values of temperature. It changes from 20.13 degrees Celsius to 41.06 degrees Celsius. So 41.06 is the final, so we will do 41.06 degrees Celsius minus 20.13 degrees Celsius. And using our calculator, this will give us 20.93 degrees Celsius. That is our delta T. All right, so now let's turn this into equation form. So Q, so we have 0.476 kilojoules equals M, 43.56 grams. C, we don't know the value, so we'll just put that in. And delta T, which is 20.93 degrees Celsius. All right, so now basically it turns into an algebra equation, and we'll be solving for C. All right, so the first order of business for this is going to be to multiply our 43.56 grams times 20.93. So we will do that with our calculator. We will rewrite the equation after that step. So this side stays the same. And now we have 911.71 from multiplying this value and this value, C. So now, like any other algebra equation, we will isolate the C, which is what we are looking for, by dividing both sides by 911.71. Okay, so now we will divide 0.476 kilojoules divided by 911.71. Okay, using our calculator, 0.000522 kilojoules per grams times degrees Celsius. Okay, so looking at our answer, looks good. Only one thing, we are not finished yet. We will have to look specifically here at our units. So we're looking for heat capacity, and when looking at heat capacity, we have to remember our units should be in joules per grams times degrees Celsius, and right now we have kilojoules per grams times degrees Celsius. So we just have to do a simple conversion rate of kilojoules to joules to get our final answer, which we will do now. So 0.000522 kilojoules per grams times degrees Celsius. So now we will look at the conversion rate. We'll make a fraction. So the only thing we have to change is kilojoules, so we can leave the grams per degree Celsius alone. So we will, the conversion rate, 1 kilojoule is 10 to the third joules. So this cancels out kilojoules and leaves us with joules up top. So now after you do that conversion rate, you will get equals 0.522 joules per grams times degrees Celsius. And that is our heat capacity, C. So I want to thank you for watching, and I hope this helps when using the heat equation.